All right, if you're in engineering, product design, or maybe you've just got a big exam coming up, you need to get your head around FMEA. So let's dive in. Consider this your ultimate study guide to nail it. So let's kick things off with a big question. In pretty much any system you can think of, from your phone to a spaceship, things can go wrong. It's just a fact of life. But what if you could see those failures coming? What if you could stop them before they even become a problem? Well, that's exactly what FMEA is all about. Here's our game plan. We'll start with what it is, cover the key terms you gotta know, then get into the math of calculating risk. After that, we'll look at a real-world example, talk about why it's so important, and wrap it up with the key takeaways for your exam. Let's get started. So, first up, what is FMEA? If you only remember one thing from this whole explainer, make it this. FMEA is all about being proactive. It's not about reacting to disasters, it's about getting ahead of them. Okay, here's the textbook definition. It sounds a little dry, I know. A systematic method, blah, blah, blah. But the key words here are systematic and prioritize. It's not just guessing what might break. It's a structured, repeatable process that tells you, hey, pay attention to this problem first. And that process really boils down to these 3 steps. First, you figure out how something could fail. Second, you think about the consequences, the so what. And third, you rank everything so you can focus your energy on eliminating the biggest risks. Simple, right? That's the engine behind the whole thing. Now, to do an FMA right, you have to speak the language. It's got its own vocabulary, so let's break down the terms you'll absolutely need to know. These are really the building blocks. A failure mode is just how it breaks, like a tire going flat. The effect is the consequence. You lose control of the car. The cause is why it happened, maybe a nail on the road. Now, the last 3 are super important: severity, occurrence, and detection. We use these to actually score the risk, usually on a scale of 1 to 10. Let's put these 3 side by side, because it's crucial to know the difference. Severity asks, if this happens, how bad is it? Occurrence asks, how often is this going to happen? And detection asks, how likely are we to catch this before it's too late? Getting these 3 right is the whole key to an accurate FMEA. So, what do we do with our ratings for severity, occurrence, and detection? Well, we use them to calculate something called the risk priority number, or RPN. This is where we turn all that analysis into a single, concrete number we can actually use. And here it is, the big one, the formula you absolutely positively have to know for your exam. The risk priority number is just severity times occurrence times detection, S times O times D. This little formula tells you where to focus. Seriously, write this one down. Okay, let's try one. Imagine a potential failure where the severity is a 9 out of 10. That's really bad, right? Could cause a serious injury. Let's say occurrence is a 3, so it doesn't happen all that often. And detection is a 2. Now here's a classic exam trip up, so listen close. A low detection score is actually a good thing. It means it's really easy to spot the problem. So, what's our RPN? You just multiply them together. 9 times 3 times 2 gives us 54. Now, is 54 a good number or a bad number? Well, on its own, it means absolutely nothing. The whole point of the RPN is to compare it to the RPNs of all the other potential failures. It's a ranking tool. All right, enough theory. Let's see how this all comes together in a real-world scenario. We're going to look at a quick and simple FMEA for a laptop's power system. Take a look at this table. See the row for overheating sensor fails? The severity is a 9, super high, but it rarely happens, and it's easy to detect, so its RPN is only 54. Now compare that to the top line, battery percentage misread. Its severity is lower, a 6, but it happens more often, and it's harder to catch, which shoots its RPN all the way up to 120. And that's the whole point. That RPN of 120 acts like a giant flashing red light. It tells the engineering team, hey, forget everything else for a second, this is your #1 priority. They'd then work on a fix, and, this is a key part of the process, they would recalculate the RPN afterward to prove they actually lowered the risk. So you've got the mechanics down, you know how to calculate the RPN, but why does this actually matter? I mean, beyond just passing your test, why do companies do this? Well, the benefits are huge. By finding problems early, companies make better, more reliable products. That saves them a fortune in warranty claims and recalls. It also creates this amazing knowledge base for the whole organization. And for a lot of industries, it's actually required to comply with quality standards like ISO 9001. And this isn't some obscure academic thing. It is used everywhere. The brakes and airbags in your car? FMEA. The flight controls on an airplane? You bet. The medical devices that keep people safe in hospitals? All of them rely on this exact process to make sure they work when it counts. Okay, time to bring it all home. We're going to do a lightning round review. If you're cramming for an exam, this is the slide you need to burn into your brain. Let's lock this in. 1. FMEA is proactive. 2. Its goal is to deeply understand what could go wrong. 3. It quantifies that risk with our favorite formula, RPN equals S times O times D. And 4. It drives action and makes things better over time. So in the end, that's what FMA really is. It's a super powerful tool for managing risk and for always getting better. So I'll leave you with a final thought. Now that you know the framework, look around. Think about a project you're on or a process at work. What hidden risks are lurking just below the surface? What could your own mini FMEA uncover? Good luck on those exams. Thanks for tuning in.